Assalamualaikum warahmatullahi wabarakatuh.
Hello guys, welcome from group to Mechamind. So in this session, we will do presentation about our project. The name of our project is Smart Delivery Robot. So before we start, we want to introduce ourselves. So my name is Gabriel as a mechanical.
My name Arik as mechanical.
My name is Indriani Gaparia as programmer.
My name is Vincila Fensha as programmer.
My name is Prima as electrical.
First, I will explain about the background of our robot. So the Smart Delivery Robot is developed to improve the efficiency of delivering small items in a workspace such as a braille. So this robot is used line-based navigation capability. The robot can operate with high precision in the busy lab environment, avoid route errors, and provide an efficient delivery solution to support practicum session and research activities in braille.
Next, I will explain about the draft design on it. This is draft design 1, draft design 2, and draft design 3. This is the front view robot, perspective view, and the back view of our robot. This is a realization of our final design.
Okay, next we have the timeline. On the first week, we did the robot assessment and problem identification. On the second week, we analyzed the requirements and improvement planning. On the third week, we developed the improvement concepts. On the fourth week, we did a finalization of improvement design. On the fifth week, we prepared the components and tools. On the sixth week, we did implementation about components. On the seventh week, we did the testing and evaluation. On the eighth week, we did the refinement and optimization system. On the ninth week, we did the implementation of improvements. On the 10th week, we did integration system. On the 11th, we test the robot's performance. On the 12th week, we did the final optimization and documentation. On the 13th week, we did the demonstration. And on the 14th week, we did benchmark and implementation. Next, we have the budget plan. Our first component is acrylic, which is three pieces with a price of 150,000. And on the second component is bracket motor, 2 pieces, 7,000 rupiah. And on the third component is spacer copper, which we needed 24 pieces. The price is 31,200 rupiah. And next we have the Moore M3. We needed 24 pieces, which costs 4,800 rupiah per piece. And fifth, we have the sensor ultrasonic, 1 piece, which costs 10,000 rupiah. And next is the battery, which 1 piece, which costs 30,000 rupiah. And next is the battery holder, 1 piece that costs 8,500 rupiah.
Okay, this is electrical wiring of our delivery robot. The robot is powered by an 8-volt battery. The battery is connected to a switch so we can easily turn the whole system on or off. The ESP is the main controller of the robot. It receives the data from the sensor, process the data, and send command to the motor driver. For line detection, we use a BFD 1000 line sensor with 5 sensor S1 to S5. This sensor detect the black line on the floor and the ESP use the data to keep the robot on the correct path. We also use an HGSR 04 ultrasonic sensor to detect obstacle. If an object is detected in front of the robot, the ESP will activate the ESP will activate the program for robot stop. The LCD use I2C communication through the SDA and SCL pins. It displays information such as the robot mode, destination table, and current status. The L298N motor driver receives control signal from the ESP and drives to two DC motor. It controls both the direction and the speed of the motors. The battery powers the whole system through the switch. The ESP read data from the land sensor and the ultrasonic sensor. Based on that data, it runs the PID algorithm and obstacle avoidance. Then send control signal to L298N motor driver. The motor driver controls both motors so the robot can follow the line correctly. At the same time, the LCD shows the robot status and other information in real time.
Okay, next we have the flow chart. So first we have start and then initialize the system. The robot will be at the store and the infrared sensor will detect all black, and then it will wait for 2 seconds and it will follow the line, and the infrared sensor will detect if there's the first if it detects the first intersection. If yes, then it will turn right. If no, then it will continue following the line. And the ultrasonic sensor will detect if there's an obstacle. If yes, then the robot will stop, and then the operator will change the mode into manual mode, and then the operator will manually move the robot to avoid the obstacle, and then it will go back to the path of the line, and the operator will change the mode into auto mode, and it will continue following the line. If the robot doesn't detect any obstacle in the front, then it will just continue following the line. And after that, it will detect the infrared sensor will check if it reaches the checkpoint, which is first checkpoint or first table. If yes, then it will stop for 2 seconds. If no, then it will continue following the line. And it will also do the same for the second table. It will detect if the robot reaches the second checkpoint or the second table. If yes, then it will stop for 2 seconds. If not, then it will just continue following the line. After that, the infrared sensor will detect if it already reached the last intersection. If yes, then it will turn right and then it will go back to store and then it will stop.
Okay, here is our robot design and the final implementation result. On the right, this is final implementation, and on the right is the design, and the left is implementation. Next. Our team consists of 5 members, 1 leader or electrical, 2 mechanical engineers, and 2 programmers. We complete the project in 14 weeks using common electronic tools. Next. This is our demonstration. In manual mode, the robot is controlled through the dashboard. In automatic mode, it follows the line and avoids obstacle by itself. Thank you. This is our presentation. Wassalamualaikum warahmatullahi wabarakatuh.